All right, hi guys. We are back here with the chemical equilibrium MCQ. So we're just going to go through the answer very quickly. Okay, let's look at question 1, right? We have this equilibrium with F plus G to give you 2H plus J. All right, in a certain 1 dm cube mixture, the equilibrium concentration of G is 10. All right, what will be the new concentration of G if 5 moles of pure G is added? Okay, so this is very purely a theory question. There's no calculation involved. You just need to know that the equilibrium will shift to the right, all right, to remove the excess. So if let's say we were to have like this amount of G, right, and we added another 5 to give you 15 of G, how will the equilibrium shift? The equilibrium will shift to the right to remove G such that the concentration will drop, all right, to somewhere between 10 and 15. All right, so that's for question 1. Question 2, which of the following statement is correct for reaction for which the equilibrium concentration, the equilibrium constant, beg your pardon, is independent of temperature? So since enthalpy change is 0, the temperature will not affect the equilibrium constant, right? So that is the correct answer. Okay, for 3, so you have carbon monoxide and hydrogen gas in 1:3 molar ratio. When it's introduced to a silk vessel and heated to 1200 Kelvin. Okay, equilibrium, it was found that total pressure was 32 atm. Mole fraction were 0.19 and 0.12. What is the value of the equilibrium constant Kp? Okay, very simple. You just need to write out the whole table, plug in your data that the question has given to us, and then take the mole fraction multiplied by 32. All right, and then we substitute into the Kp expression. Then voila, we'll get our answer, right? So that's for question 3. Question 4, so we have this equilibrium again, and we note that the delta H is less than 0. So it's an exothermic reaction, right? So they told us that after the equilibrium was reached, system was disturbed and changes to the system were monitored. Okay, so these are all the changes that has occurred lah. Okay, what was the disturbance applied? All right, so the answer is compression of the reaction mixture, so means that volume decrease, right? Okay, when the volume decrease, the pressure of all of them will increase. All right, so all of the concentration of the substances increases. The rate of forward and backward reaction will all increase. All right, Kp will remain unchanged as temperature is not changed. All right, so our answer is C. Okay, for 5, it shows us the Haber process, right? How it varies with temperature at pressure P1 and P2. So the question here is, which option is correct? Okay, we chose option A, X is less than 0. Okay, I think other than the fact that we know this equation is exothermic, that is a fact, we're supposed to know that. On top of that, right, with increasing temperature, we notice that increasing temperature, so as we go from left to right, the fraction of NH3, right, the product decreases. Okay, so the forward reaction must be endothermic. So at the same temperature, right, if we draw a vertical line that cuts both graphs, Okay, sorry, my line not very vertical. Okay, you notice that the fraction of your product ammonia, right, is more in pressure 1. So pressure 1 should be the higher pressure that causes equilibrium to shift towards the right. All right, that's how we got the first answer. Okay, let's look at question 6. So we have this equilibrium shown by this equation, L plus M, and we get Q plus R. Okay, so we carry out 2 experiments and we measure the rate of production for R. Okay, what changes might explain these results? Okay, so our answer is 2 and 3. 1 is not going to explain this result because it will change the yield. All right. Okay, question 7. Okay, so the question gives to us the equilibrium with the Kp at different temperatures. Which statement is correct? The yield of carbon dioxide increases with temperature. All right, so forward reaction, Kp increased, as we can see from the question, right, from here 10 to the power minus 3 to 1.5. It actually increased when we increase temperature. So forward reaction is endothermic. Okay, so we're going to get more product when we increase the temperature. That's why B is correct. All right, 8. Okay, so we're given this equilibrium for Al2Cl6. A sample at pressure 0.72 was placed in an empty container, allowed to reach equilibrium at 500 Kelvin. Okay, so the total pressure is 1.2, which statement is correct? So if you go and check out all 3 options, right, you realize that they are all correct. Okay, so if we calculate degree of dissociation, we will get 0.67. Okay, so when the volume of container is half, means that pressure increase, right? Pressure increase, equilibrium will shift to the left. It will shift to the left to produce less molecules of gases. Both the rate constant and the rate equilibrium constant, would increase with temperature. And that is true because forward reaction is bond breaking. It is endothermic. All right, so rate and the Kp will both increase with temperature. Okay, so graph here shows the percentage of gaseous products present at equilibrium at various temperature and pressure. Which one of the following reaction could it represent? So we see that as temperature decrease, there's actually more product. So forward reaction is exothermic. All right. At higher pressure, as you go from left to right on the graph, there are less product. So there must be more gaseous product compared to gaseous reactant. Okay, so when we have higher pressure, right, what happens is the amount of product decreases. The amount of product decreases. So it means that reaction must have shifted to the right. Sorry, shifted to the left. Okay, so if you look at this equilibrium, the carbon is a solid. All right, so there's just 1 oxygen gas and 2 carbon monoxide. So equilibrium will shift to the left towards less molecules of reactants. Okay. Okay, sorry, I think these 2 should be. switch. Okay, so we come to our last question. L and M can react together in an equilibrium. Okay, so in this experiment, 1 mole of each of L and M were reacted at constant pressure P and temperature 350. Amount of R, the product, present in the mixture was recorded. The experiment was repeated at the same pressure but at temperature that is twice of the initial temperature. All right, so what happens when we increase the temperature? The U actually decrease, right? Okay, so what cannot be deduced from the graph, we do not know whether the activation energy is high or low. There's no way we're gonna know that. All right, so that's it, folks. That's all the question that we have for you. Hope you had a fun time doing these questions.